Hi everyone! It is the time for us to go to the next experiment, which is half effect experiment or determination of charge carrier density. But as usual, we go log into our account and then go to physical sciences and scroll down until you find the solid state physics virtual lab and then choose the half effect experiment. And then after that, you can see as usual there are theory, procedures, self-evaluation, simulator, assignment, reference, and feedback. To start the simulator, we go here and then here is the simulation. But before we start the simulation, we need to know what you can see in the screen. Okay, so before we started the simulation, I'm gonna explain to you what are these. At first, as you can see here, there are controls such as combo box, which is select procedure here. There are two types. There are magnetic field, current, and then half effect setup. This is used to select the part of the experiment to perform, and then there are select material here. But the slider activates only if half effect setup is selected. Like this. So you can see here there are four choices: germanium, aluminum, copper, and then gold. And then there are insert probe here, show voltage, and reset. And there are also a slider, which is their current, thickness, and Hall current. So this current is used to vary the current flowing through the solenoid. And then the thickness, the slider used to change the thickness of material selected. And then the Hall current is used to change the Hall current. Okay, now we're going to start the simulation, but don't forget, guys, to always read the procedure first. Okay, so to measure the magnetic field generated in the solenoid, first we need to do is select the magnetic field current from the procedure combo box. And then click Insert Probe button. And after that, place the probe in between the solenoid by clicking the wooden stand in the simulator. Like this. And then after that, using the current slider, varying the current through the solenoid, corresponding magnetic field is to be noted from Gauss method. You can see here. And then all we do is just for this, we only move the slider from 1 ampere, and then we see the result here on a Gauss meter, and then write it to the table. And then after that, we go increase this to 1.5, and then there's the result. Put it on the table. And then 2 ampere, as you can see, the result is 0.2964, and then write it on a table. And then we do this until the current is 5 ampere. And now we're moving to half effect apparatus, and then first thing we do is select effect setup from here. We select the half effect setup, and then after that click insert hub probe, and then click the wooden, and then after that set the current slider value to minimum, which is 1 ampere, and then after that select material from select material combo box. Here I'm going to choose gold, and then after that select thickness of the material using slider thickness. We're choosing the minimum value too, which is 0.0001 meter, and then select the Hall current using the slider Hall current, and then we use 1 milliampere. And then after that, note down the corresponding Hall voltage by clicking Show Voltage button. Here is the value, and then calculate Hall coefficient and carrier concentration of that material using the equation that is served. And then repeat the experiment with different magnetic field. Thank you for watching.